Hello Math 109, we are still on chapter 5. This is part 4. Picking up on number 33 where we left off last time. Finding the complex zeros. So what would I do to solve this one? Again, I can go to the calculator and I can either do it in my graph or do it in my app. I think I'm probably going to prefer to do it in the app. So let me just start back over with the app. So I click apps, I click option 9 for, well, it might not be option 9 for you, but on my calculator it's option 9 for PolySimult. I'm going to click option 1 for polynomial root finder. My degree is 3. I'm just going to then click the next button by clicking the graph, which is the button below next. I'm going to type in my coefficients. 1 is my first coefficient. -7 is my second coefficient, so I'm going to type in -7 right there. 25 is my next coefficient. And -39 is my last coefficient. And I click solve. And actually, this one was so easy because the app did it all for me. The reason the app can do it all here is because these are rational imaginary numbers, not irrational. So typing them as an exact answer won't be a problem. I can type them just like that. That's going to make it a lot better, a lot easier for this problem. So 3 and 2 plus or minus 3i. All right, let's type that in. Okay, let's go back to our, hope I can remember the answers, 3 and then 2 plus or minus 3i. I think that was it, if I remember. Yep, that was it. And now it wants me to use those zeros to factor it. So it's going to be x minus 3, x minus parentheses 2 plus 3i, close parentheses again, and then x minus parentheses 2 minus 3i, close parentheses. That should be good enough for the answer. So all I did was just, all I'm doing to do that is just, I'm taking the 3 and I'm doing x minus 3. I'm taking the 2 plus 3i and I'm doing x minus 2 plus 3i. I'm taking the 2 minus 3i and I'm saying x minus 2 minus 3i. And that's how you do it. That's how you turn a 0 into a factor, is you just say x minus whatever that 0 is. We could clean this up some, and I would probably prefer to clean it up some, but since we don't have to for MathXL's sake and it accepts the answer as it is, I'm just going to leave it like that. All right. Moving on to number 34. This one I would do it by factoring because I can. I prefer to factor if possible, and this one is definitely possible to do by factoring. I'm going to factor it like this. These two terms have to multiply to get x to the 4th, so that's going to be x squared and x squared. And these two terms have to multiply to get 121 and add to get 122, so that's going to be plus 121 and plus 1. Okay, so now that's how I can factor it, and then I can set this equal to 0, set this equal to 0. So x squared plus 121 equals 0. I'm going to solve this just using good old algebra, the square root method. Square root both sides now. So x equals plus or minus 11i. Since 11 is the square root of 121. And then this part, I do this part equal to 0 as well. Again, solve it using the square root method. And so square root both sides here, and x equals plus or minus square root of -1 is I, so plus or minus I. So plus or minus 11i and plus or minus I are my answers, and that's all of them. That's all of the complex zeros for this problem. I have 4 total zeros for this problem, and they're all complex. So plus or minus 11i, comma, and then plus or minus I. Moving on. Oh, I gotta factor it using that. So x plus 11i, x minus 11i, x plus I, x minus I. 35. Finally, we get to a different topic, different kind of concept to learn. I mean, it's still related, but use the graph of the function to solve the inequality. All right, let me show you how we can do that. Part A, f of x greater than 0. Where is this thing? Where is this polynomial greater than 0? It's greater than 0 here and here. That's it. And so we're just looking for the values of x where that's true. Well, that's true for all of these values of x, right? From negative infinity to negative 1. And it's also true for this part. What are those values of x? Well, that's just between 2 and 3. 2 to 3. Now notice I put parentheses. Notice I put parentheses on these because it says greater than 0. Well, at this point here, I'm not greater than 0, I am 0. But I can't be 0, I got to be greater than 0. It doesn't have an equal to sign, there's no equal to sign there. Same here, the 2 and the 3 are not included because at 2 and 3 I'm equal to 0, not greater than 0. So again, those aren't included, that's why I put parentheses there instead of brackets. So my answer to part A is exactly what I have showed you right here. All right, let's do part B. Part B is f of x less than or equal to 0. All right, where is that the case? Where is it less than or equal to 0? Well, throughout here and throughout here. All right, so what is that? That's going to be all throughout there on the x-axis and all throughout there on the x-axis. So that's going to be from negative 1 to 2, right? Negative 1 to 2. And I'm going to have brackets on that. Why? Because the negative 1 and 2 are 0, and it's including 0 here because it's less than or equal to 0. And also starting here from 3 on to infinity. 3 is included to infinity. Infinity is never included. Infinity always has a parentheses. So this is the exact way that you should type in the answer to part B. Let me go ahead and type those answers in just to make sure that I'm telling you about how to type in the answer correctly. So part A was negative infinity to negative 1 union 2 to 3. Yep. And part B is it's going to be a bracket. The only way I can get a bracket on here is to use my keyboard on my computer. There's a bracket beside the P, left bracket beside the P, and a right bracket beside that. So left bracket, negative 1 to 2, union, bracket, 3 to infinity, parentheses. Good deal. All right, let's work on this one. Again, we are using the graph to get the answer. So for part A, f of x greater than 0. Where is f of x greater than 0? In other words, where is it above the x-axis? Well, throughout here, which is just from here to here on the x-axis, and also throughout here, which is from here all the way there on the x-axis. So let me go on this. So it's from here to here, and so that's going to be from negative 1 to 0, and it says greater than 0, so not including 0. So Now, negative 1, I'm going to have to put a parentheses. I can't include that because at the value negative 1, is it up here or is it down here? That's an asymptote right there. It's undefined right there. So it doesn't know if it wants to be positive infinity or if it wants to be negative infinity. It's kind of undefined right there. So I can't include the negative 1. I cannot include the negative 1. But everything beyond negative 1 is good until we get to 0. I also can't include the 0 because it's got to be greater than 0. It can't be when it's on the x-axis. It's got to be above the x-axis. Union, all right, from here to infinity, right? So what's that? That's from 2 to infinity. And again, I got parenthesis on the 2 because at 2, I'm on 0. I got to be greater than 0, not on 0, and I don't include the infinity. So that's the answer to part A. Let's go on to part B. Part B is f of x less than or equal to 0. So that is going to happen here. So all throughout there on the x-axis. And where is it less than 0? Also here, right? So that part of the x-axis. So like from negative infinity all the way to there. So negative infinity to negative 1. I can't include the negative infinity. And I also can't include the negative 1 because at negative 1, it's that asymptote, that undefined value, that identity crisis for the function. Union. And then from here to here. So that's from 0 to 2. I'm going to include the 0 because at 0 I am on 0, which means that, and it's less than or equal to 0, so I can include the 0. At 2, though, I can't include the 2 because, again, that's the asymptote undefined identity crisis value where you can't really say what it is. So this should be a good way to type in the answer to part B right there. Moving on to the next one. $37. Okay. Where is this thing less than 0? Where is this thing less than 0? Down here, and that's it. What's that on the x-axis? What values of x, in other words, make that true? What values of x solve that inequality? Well, from negative infinity all the way until there. Right at that point right there, I am no longer less than 0. I am on 0. So I can't include that point. So I've got to say negative infinity to 0. And then union from here to here. So from 0 to 4. And again, I can't include it because I'm on 0 here. I got to be less than 0, not on it. So this should be a good way to write your answer for that problem. Let me just say one thing. If it was f of x less than or equal to 0, then it would have just been all of this. It would have included all of that without stopping. It would have just been negative infinity all the way to 4, and it would have included the 4. Let me show you, see if you can see it better. So like all of this is less than or equal to 0, right? And even the part where I'm on 0 is included there. So it would just be from I'm less than 0, less than or equal to 0, less than or equal to 0, still less than or equal to still less than or equal to 0, still until I get to here. So from negative infinity all the way to 4. Okay, again, we're solving this inequality. We're trying to find where this thing is less than or equal to 0. Where is that the case? It is down here and down here. And where is that on the x-axis? On the x-axis, what values of x, in other words, what values of x make that true? It's these values. For all those values of x, we're down here. And these values. For all these values of x, we're also down here. So what is that? That's negative infinity all the way to there. Negative infinity to negative 2. And I'm going to include the negative 2 because we're less than or equal to 0. Union. This from here. So 3 to infinity. Include the 3. Never include the infinities. That's the answer to that problem. That's pretty simple. Move to the next one. We're closing in on the finish line, guys, for chapter 5. $39. Okay. Where is this thing less than or equal to 0? Where is it less than or equal to 0? Only here. That's the only place. And so as far as the x values are concerned, it's just there. So from here to here. So -2 to -1. I will not include the -2 because -2 is where we have an asymptote and we have this identity crisis. So can't say anything about the -2 to include it. But I will include the -1 since it's less than or equal to 0. So -2 to -1 should be the answer to that one. All right, let's go on to the next one. Number 40. All right, on this one, they do not give us a graph. What are we going to do when they don't give us a graph? I'm going to show you 3 ways you could go about this. One way is to graph this in your calculator and just look at it from there. If you find that to be the easiest way to do it, go right ahead and do that. So we got x plus 5 squared, and we have x minus 3, and we graph it. And we can kind of see what this graph looks like now. So we're trying to find where this thing is greater than 0, so only this part of the graph, right? So only right there. So it would be from 3 to infinity. 3 to infinity is the solution with parentheses on it. Another way you can do it is just to make a graph by hand. So you know what the zeros are. Just pretty easy to know that the zeros are -5, and that's a double root, and 3. And this is going to be an x cubed blah 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 function, right? So it's going to look something like that. So 1, 2, 3, 4, 5, and 1, 2, 3. I'm going to cross the x-axis there. I'm going to look like I'm going to have my right arm up and my left arm down. I'm going to cross at 3. I'm only going to touch at 5. So crossing there, touching there. And I have drawn my own graph without having to type it in the calculator. And I know that the answer is this part right here. So as far as the x-axis is concerned, it's all that on the x-axis. 3 to infinity, parentheses. And there's a final way you can do it as well. One more way. And that is we can just put the zeros -5 and 3 on a number line. -5 and 3. And then we can just test values on the number line that are in these regions. Let's say I have a region. Here's a region here. Here's another region here. Here's a third region here, right? The regions are broken up by the -5 and the 3. So maybe I could test -6. Let's test -6. So -6 plus 5 squared times -6 minus 3. Well, what's that going to be? -6 plus 5. That's going to be -1 squared. And that's going to be -9. What's that turn into? That's 1 times -9. That's -9. Is -9 greater than 0? Is that true? No, it is not true. So that means this region is not one of the solution regions. Now test something between -5 and 3. Well, the easiest one to test between there would be 0, I think, in my opinion. Let's try 0. 0 plus 5 squared. 0 minus 3. That's going to be 25 times -3. That's going to be -75. is greater than 0. Is that true? Is negative 75 greater than 0? No, it's not true, which means this is not a solution region either. So then let's test out this region. What's the number? Maybe try out 4. Let's test out 4. 4 plus 5 squared. 4 minus 3. That's going to be 4 plus 5 is 9. 9 squared is 81. 4 minus 3 is 1. 81 times 1 is 81. 81 is greater than 0. Is that true? Yes, it is. So this is the solution region. 3 to infinity. That is the other way you can do those kinds of problems. So whichever one of those ways makes most sense to you is good to do. Same kind of strategy here. You can do any of those 3 strategies we just talked about. So let's find our zeros. Let's factor it. Factor out the GCF, which is x squared, and then solve it. So we get x squared equals 0. Square root both sides. X equals 0. That's a double root. And then x plus 10. And so x equals negative 10. So then I could graph my own graph. Negative 10 and 0. 0 being a double. I have an x cubed function. It's a positive leading coefficient. So my right arm is up. It's going to look something like that. I'm going to just touch at 0. I'm going to cross at negative 10. So it's going to look something like this. And if I graph it in the calculator, that's what you would get in the calculator as well. So let's see. Where are we less than 0? The only place I'm less than 0 is down here. Which means that the only values for x that make that true are these values for x. What are those values for x? Those values of x are negative infinity all the way to negative 10. So negative infinity to negative 10 would be my answer. Again, the other way you could do this is to put those zeros, 10, on a number line and test values in the regions that are sectioned off by that number line. So maybe you could test out negative 11. You could test out negative 1. You could test out 1. And just see if it comes out true. If it comes out true, then that's part of the solution. If it doesn't come out true, it's not part of the solution. I'm not going to keep going with that because I showed you how to do that in the previous problem. And the other way to do it is to just graph it in your calculator and look at it there. Again, whichever one of those 3 methods seems good to you is fine. Same situation here. All right, to solve this, find the zeros, I would you could graph it in your graphing calculator or do the app, or we can solve it by factoring. I can factor out a GCF, which is an x. It leaves me with x squared minus 4x minus 12, and then that factors as x minus 6, x plus 2. So I get x equals 0, I get x equals 6, and I get x equals negative 2. And they're all single roots. And it's an x cubed with a positive leading coefficient. Again, it looks like that. So 1, 2, 3, 4, 5, 6. 1, 2. So there and there and there are where I'm crossing the x-axis. So something like that. Where is this thing greater than 0? It would be here and here, right? As far as the x-axis is concerned, that means it would be here on the x-axis and here on the x-axis. So that's from there to there. So that's negative 2 to 0. Greater than 0, so I don't include it. So that. and from 6 to infinity. -2 to 0 and 6 to infinity. I believe choice C is the correct one. All right, moving to the next one. All right, this is our last one. I would probably encourage you here, since this is not a polynomial, to graph this in your calculator, because it would be good to get a look at what this looks like. So we've got x minus 6 squared over, or you could say divided by, x squared minus 9. Let's graph it and take a look. Yeah, that's a very strange looking graph, isn't it? Where's this thing greater than or equal to 0? This is going to be interesting, isn't it? My question is, well, I know it's greater than 0 up here. I know it's greater than 0 here. My question is, what's going on right here? Does it go below 0 here? I'm going to have to zoom in on that. I'm going to go zoom box. That's option 1. I'm going to draw a box around the part that I want it to zoom in on. Whatever box I draw, that's going to be the new screen that it's going to do. Let's see. Second. Okay, I forgot. I think it got out of zoom box. If I want this to be the first corner of my box. So I hit enter there. Then I go down. And I'm gonna draw my box kind of like this. I'm putting the cursor where I want my other corner of my box to be. So I'm thinking like right there. That's kind of what I want to see. Okay, I think I can tell now it doesn't cross the axis. It just hits the axis. It hits the axis at whatever value that is. But I want to zoom in one more time. I think I need to zoom in and make myself feel better about it. I'm going to go zoom box one more time. Actually, I think I'm just going to go zoom in. Zoom in. So if I hit zoom in option 2, I'm going to zoom in right there. If I can ever get there, it takes so long on this computer. And that kind of just confirms my suspicions that it just hits that x-axis right there. I'm going to calculate that 0. I'm almost positive it's going to be 3. Let me try it and make sure. Or it might have been 6. I can't remember where I actually was. I'm too zoomed in to even tell where I am. Let me try that again. Notice too, all these values, my y value never becomes negative. It's always something like times 10 to the -6. That's like really close to 0, but it never actually becomes negative. So that tells me as well that it never crosses that axis. All right. It never crosses. It just hits it. And I think it hits it right somewhere right in there, which the X value is like 5.99. So I know it's pretty much 6. So let me come over here to where I copied that. I think I copied it. Let me zoom back to my standard zoom window. Zoom 6. I'm going to take a picture of that now and show you what I think is the answer. Where's this thing greater than 0? Right there, and right there, and all throughout there too. Like it's always greater than 0, except right here. Right here it's equal to 0, but I can be either greater than or equal to 0, right? That's greater, so that actually gets counted too. So my answer is going to be everything throughout there until I get to this asymptote. This asymptote appears to run right in here, maybe. Maybe it's right there. It's possible that it's there. I'm not 100% sure. And then this asymptote is probably right there. So I believe my answer is going to be negative infinity to either -3 or -2. I'm not sure which. I'm going to say -3, and if it's not right, I'm going to try -2. And it's at -3, we have that asymptote identity crisis, so that's not included, so that is going to be part of my answer. And then this part is from here, so 3 to infinity. Include the, nope, that's an asymptote, don't include the 3. 3 to infinity. Let's see if that's the answer. Negative infinity to -3. Union 3 to infinity. Yeah, that should be option C. Option C should be a good option. Let's choose that and make sure we're right. That was a pretty tough little problem. Yep, that's correct. All right, that was the last problem of Chapter 5. So we are done with Chapter 5. Good luck on that assignment. And I'll see you again in Chapter 6.